8.3, which is about complex numbers. Right, and these complex numbers are really interesting because what we see is, it's a different type of system, right? So before we do that, let's just talk about this number I. Right, so this number I is defined as the square root of -1. And what we can say here is that I squared equals -1. Right, so I equals the square root of -1, and I to the power of 2 equals -1. And this should make sense mathematically, right? Because let's check it, right? If we have I equals the square root of -1, one of the things that we can do is we can get rid of the square root by taking each side to the power of 2, right? That removes the radical symbol and that power of 2, and we're left with I to the power of 2 equals -1. As you can see, that's what we get there. All right. And this imaginary number, or this I, is something that's really interesting, and we'll see here with some examples, right? So let's take a look at our first example. It tells us to express each number in terms of I. We start off with our first example, which is the square root of a -7. Right, so we can always rewrite this as the square root of -1 times 7, right? And we can rewrite this as -1, the square root of -1 times the square root of 7, right? And then from above, we learned that the square root of -1 is just I, right? So now what we can say is this is just I times the square root of 7, right? Or we can show it as I square root of 7, or if we want it, we can show it as a square root of 7, and then the I outside of the square root symbol, right? Make sure you note that the I is outside of the square root symbol. So that's a very nice first example. Any questions with that example there?
No.
Okay, so let's take a look at our next one, example B. How about one more? We do negative the square root of -13. Right, so same idea, right? Maybe we can go about it just a little faster here. When we bring down our negative sign, right, you can just rewrite it as a square root of 13 and then put the I on the outside. Right, or we can show it as negative I square root of 13. Right. One thing to really notice, which I think is really interesting here, is just that if you have a negative inside that square root, right, you take a look at the answer, all of a sudden, you just rewrite it, right, where the radicand, that 7 stays at the inside, the minus sign is gone, and now we put an I on the outside. Same thing with this example here. We had a negative in the inside. All of a sudden, you take a look at our answer, right? The 13 is still there, and then we just put the I on the outside and get rid of that negative sign. Right. But I think one more example is good to look at because we learned in the previous chapter that we can simplify radicals as well, right? So square root of -48 right? So because it's the square root and we have a negative, right away we can just write it as I square root of 48, right? But we don't want to stop there. We want to see if we can simplify this 48 even further. I like to show factorization. I like to break up this 48, right? We break up 48. We can divide it by 2 if we wanted to, right? That's a 2 and a 24. We break up our 24. We can divide it by 2. That's 2 and 12, right? We break up our 12s to 2 and 6, and we break up our 6 to 2 and 3, right? So now I have I square root, and I'm no longer using 48, but I'm going to use all these prime numbers. Instead, I'm going to put them inside. 2, 2, 2, 2, and the 3. Right? And when we don't have an index, right? When we don't have an index here, right? It implies that your index is 2 and you're pulling in groups of 2s, right? So I can pull one of those out and I can pull one of those out, right? So that leaves me with an I. One of those 2's got pulled out, another 2 got pulled out, and the inside I'm only left with 3. And I multiply this out, right? I'm left with 4I square root of 3. Or you can also write it as 4 square root of 3 with the I afterwards. All right, so this one's a little nicer because we did have to simplify that quadratic in, right? Any questions with this example C?
No.
All right, so you know, we're looking at this number I. The number I really important to understand because what we see now is that we have complex numbers. And this is huge in college algebra, right? Huge in college algebra. Complex number, right, is a number in the form of A plus BI. All right, it's a number in the form of A plus BI. Where this is a real number and this is an imaginary number. Right, where we have a real number and an imaginary number. Imaginary, that's very interesting there, right? And this is really what this chapter is all about, right? This chapter is about working with complex numbers, so imaginary numbers. Real numbers are things that we can relate to, right? Right, you look at your real number line, right? I mean, these are numbers, 0 over here, maybe 10 over here, negative 10. Anything in the middle of it is a real number, right? So 0, right? These numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are real numbers. Even something like 0.5 is a real number, right? Maybe even something like, let's say, how about like 10 over 3, right? 10 over 3, right, gives us a number like 3.333. I mean, we can still find that number on the number line, right? Even something like the square root of 24, right? The square root of 24, if we do that, right, what does the square root of 24 give us? That gives us something like 4.898, and it continues on. So these are all real numbers, right? But all of a sudden, we look at something like the square root of negative 16, for example. First, you'll notice that if you put this in your calculator, right, it reads something like error because it's not possible, right? We talked about square roots in the past. Something times something to gives you negative 16. Not possible, right? Right? Something times something equals negative 16, right? Not possible. And I think I even lectured that in the previous video, right? 4 times 4 is 16. Negative 4 times negative 4 is 16. But there's no way that these two can be the same, right? There's no way these two can be the same. So I think that's interesting in itself, right? We know that we put that in the calculator and we get error, and the same thing, we can't multiply a same number by a same number to get this negative 16. But now all of a sudden we throw in this I, right? Now we use the number I. And we say, well, hold on. This is the same thing like saying I square root of 16. And the square root of 16 gives us 4. So now we're saying, hey, negative 16 doesn't work. Square root of negative 16, not possible. But we see here what we get is this 4i, which looks in the form, if you recall, we have a plus bi, where we call this a complex number. And this looks like it's your bi, which is your imaginary number, right? Imaginary numbers different from real numbers, right? Important to understand that imaginary and real are different. A real number can be plotted on a number line. Imaginary number is not found on the number line, right? Not found on the number line. And that's what makes it so significant, right? Not found on the number line. So we call it imaginary, right? And this is that next step in mathematics, looking at numbers. Great, I think a great topic in a college algebra class. I've looked at my math courses that I've taken. I've looked at math in space, right? So here we're saying, hey, this isn't found in the number line, yet we can still do math behind it. So what we can do here are a few things with these imaginary numbers, right? Some of the things that you can do is you can add or subtract them. Right? We take a look at an example like 8 plus 6i plus 3 plus 2i. Right? So we can definitely add these, right? These are like, right? 8 plus 3. All right, we're just collecting our like terms, right? Gives us an 11, and then we have these two, right? 6i plus 2i, right? They're like terms, right? So that gives us an 8i. Now these are unlike, so we are done looking at it in the format of 8 plus bi. Right, so once again, all we really did was just add, right? Add. 8 plus 3, 6i plus 2i. Right, so a nice example there. Any questions here?
No.
All right. Taking a look at our next one here. We can subtract it as well. How about 4 plus 5i minus 6 minus 3i? This time, just be careful. We're doing some subtraction instead, right? So now it's 4 minus 6. Right, it's 5i minus a negative 3i. Right, so what do we get? We get a negative 2, right, plus a 8i. Let's get it in that proper form. All right, in that proper form. Looking okay so far?
Yeah.
All right.
Yes.
Okay. Cool. Not only can we add and subtract, we can also multiply them. Right, so first example, square root of negative 16 times the square root of negative 25. Right, so I mentioned this a little earlier. Square root of a negative, we can just rewrite it. I square root of 16, right, times I square root of 25. And then we can simplify each one of these square roots, right? These look like they're nice ones, right? This is now just a 4. I'm going to bring the I back, right? This is a 5. And I bring the I back. And now I'm just multiplying these, right? We're multiplying these. So we multiply this. 4 times 5 is 20. We have 2i, so it's I to the power of 2. We looking okay so far? Any questions? And now we have one last step, right? We talked about this this number I, what it meant. I to the power of 2 equals negative 1. So now we have 20 multiplied by negative 1, and we see this answer to be a negative 20. Right, because at the very beginning when I talked about the number I told you that I squared, I to the power of 2 equals negative 1. All right, so a nice example there of multiplying these two radicals. Questions? Okay, I'll move on then. Okay, so now how about we take a look at this one where we have open parentheses 3 minus 7i close parentheses to the power of 2. All right, so this power of 2 means that we got 2 of them. Right, and we did this in the previous exam, some of the material that we looked at, multiplying polynomial by polynomial, specifically binomial by binomial. We can distribute here, right? We can distribute this 3 and multiply both of those. All right, so we get 9 minus a what? 21i? right? And then we also distribute this negative 7i to both of them, which gives us a negative 21i, negative, 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 positive, positive 49i to the power of 2. Questions? Okay, we can combine these two. These are like, and we can also do this I to the power of 2. All right, so now we get 9 minus, what is that, a 42i plus 49 times a negative 1. And then we see that we can actually do this, multiply that, right? So we get 9 minus 42i minus 49. And then we combine this one and that one. So 9 minus 49 gives us a negative 40 minus 42i, and we see that we have it in the correct form, a plus bi. If I'm not mistaken, I think your homework was going to say shorten the form of the complex number, which is a plus bi. Any questions? Any questions? All right. Now we're going to get to some fun ones. I really like these. And sometimes these are ones that really just get students quite a bit. Excuse me. I squared, we know, is negative 1. So now, what does I to the power of 3 equal? Well, I to the power of 3 is the same thing like saying I squared times I, right? And we know that I squared equals negative 1. We bring everything else down. So here we see that I to the power of 3 equals negative 1i, or just negative I. So I hope you understood this and didn't get lost, because now we're going to continue this. So if you do have questions, please ask. Otherwise, my assumption is that you're understanding it. So now, what does I to the power of 4 equal? Well, according to what I just did, I can say that I to the power of 4 is I to the power of 2 times I to the power of 2. All right? Or in other words, I can say it's I to the power of 2. We got 2 of them. And I know what I to the power of 2 is. I to the power of 2 is negative 1. And I bring everything else down. So I to the power of 4 is negative 1 to the power of 2, which just equals 1. Right, so I have my first one, I second, I have I to the third, and over here I have I to the fourth. So then what about I to the power of 5? Well, I to the power of 5, we can say is negative. I'm sorry, we can say is I to the power of 2. That's to the power of 2 times I. Do y'all agree or disagree? Or I'm not sure. Or what in the world is he talking about? All right, here we multiply 2 times 2 is 4. That's like 1. 4 plus 1 gives us 5, which is what we're shooting for. All right, because now I can say this here is a negative 1. Bring everything else down. So I to the power of 5, well, negative 1 to the power of 2, negative 1 times negative 1 is 1 times I. Because what if we go big? What if we go real big? I want to know, and this is what you're going to see on your test, and this is the work that I expect to see. If you just give me a number and you get it right, and you're just like, "Whew, I got it right," well, that's 1 point out of the 5, which is not a whole lot. What if I gave you I to the power of 98? Well, I'm always shooting for powers of 2s, so I'm just going to do 98, and I'm going to divide it by 2. That gives you a really nice number like 49. So now I can say I to the power of 49 to the power of, I'm sorry, let me take that back. Always in the inside is 2. I to the power of 2 to the power of 49. This would be the work that I expect to see. Because I to the power of 2, that equals a negative 1. Then all you have is negative 1 to the power of 49. And negative 1 to the power of 49, I mean, that you can put it in your calculator, but you should also understand if it's an odd, this answer is just negative 1. So that would be kind of the work that I expect to see for a problem like this. Maybe you don't have to show this part there. You can do that mentally if you wanted to. Any questions with I to the power of 98?
No.
And how about one last one? How about I to the power of 1,237? So the same idea, right? We're going to divide it by 2. Here we see we're going to get a decimal, right? So that means it's definitely going to be I to the power of 2 to the power of 618. Right? And what does that give us? I mean, if we do 618 and we multiply it by 2, what do we get there? 618 multiplied by 2. That gives us 1, 2, 3, 6. But we need it to be to 7, right?
Mm-hmm.
So this is why we do I to the power of 2 to the power of 618 times I to the power of 1. Because now if we were to work all this out, that's how we get the 1, 2, 3, 7. 2 times 68 plus 1, right? Does that make sense there? Am I going too fast? We okay here?
No, it's fine.
Okay. So now we can actually do this, right? I to the power of 2 gives us a -1. So we have -1 to the power of 618 times I, and -1 to an even number will give us a +1. So then this ends up being just I, or 1 times I, or in other words, this answer is just I. All right, so you can expect something more like I to the power of 98 or some kind of weird number like that, or I to the power of 1,237. I'm going to give you something like that on the exam, and not something like what we see on the left-hand side. Those are too easy. So some nice examples there of multiplying. And then I think what we'll also talk about here a little bit, and I'll definitely elaborate in the next section, is the idea of the conjugates of a complex number. Right, the conjugate of the complex number. So the conjugate of A plus BI is A minus BI. So these two imaginary or complex numbers are called complex conjugates. So A plus BI and A minus BI are called complex conjugates. And if we multiply complex conjugates, it just gives us a real number. Or let's say the product of complex conjugates is a real number, which is really nice, and is going to be important as we continue in this chapter. If we multiply complex conjugates, it just gives us a real number. So let's take a look. We have open parentheses 5 plus 7i. Its conjugate would just be 5 minus 7i. Right, so we saw a problem like this earlier. All we're going to do here is just multiply or distribute, right? So what do we get? We get 25. 5 times 5 is 25. Minus what? 35i. We multiply again. And here we get a plus 35i minus a 49i to the power of 2. And we'll notice that these are opposites. Those cancel out. That turns into a -1, right? So now we have 25 minus 49 times a -1. Or in other words, it's just 25 plus 49, and we get an answer of 74. multiplying conjugates gives us a real number, right? As we just mentioned. You multiply complex conjugates, you are given a real number as the product. And one last thing in this section, which I think is also a very important topic to understand, is that conjugates are used when dividing complex numbers. So when you're dividing complex numbers, you got to use a conjugate. So let's take a look at an example. Right, we want to simplify 2 minus 5i over 1 minus 6i. One thing to understand is that we never want a complex number in the bottom. Right, we never want I in the bottom. So let's rewrite this. Let's rewrite this fraction. All right, we never want I in the bottom, so we're going to rewrite this fraction. What we do, how do we do it? We multiply top and bottom by the conjugate of the denominator. We multiply the top and the bottom by the conjugate of the denominator. Anyone know why? Why would it be a good idea to multiply by the conjugates of the denominator?
It was a real number.
Very good. Great job. It gives us a real number, right? That's what we just talked about, right? If we multiply by 1 plus 6i, multiply by 1 plus 6i. We just did this earlier, right? We multiply here, here, here. That's going to give us a real number, right? So that's going to give us a real number. So then we also have to do it here, though. So great job. Right, so we simplify the top, gives us a 2, right? 2 times 1 is 2. Then we have 2 times 6i, gives us this positive 12i. Negative 5i times 1 is a minus 5i. Negative 5i times a positive 6i is a negative, 30i to the power of 2. Catch a mistake, just let me know. Right, and we're doing the same thing at the bottom. It should be just 1 plus 6i minus 6i minus 36i to the power of 2. And you just start simplifying the top and the bottom, right? You start combining your like terms up here, your I squared, right? You got an I squared here. Those will cancel out. So we got what? 2 plus a 7i minus 30 times negative 1. The bottom looks like 1 minus 36 times negative 1. And we can do a little bit more work here. I'm going to start going this way. 2 plus 7i plus 30 now, right, over 1 plus 36. And we want to be careful here. So we continue on here. What do we get? A 32 plus 7i over 37. But remember, we need a short answer in this a plus bi form. So this is really 32 over a 37 plus a 7 over a 37, and we show the I afterwards. Because we always want to show in our complex number 4. Now I don't think these fractions reduce any further, so that is our solution there. Any questions? Any questions with this 7.3?
Yes.
Okay, so